Hello everyone, my name is Brinke and I'm a senior researcher and leader of a research group at the University of Applied Science in Münster, Germany. I'm very pleased to be able to present an exciting project at this great conference, the energy supply of the new development area Warendorf in the Brinke. Why this area is worth to be presented here in this form, I will report in my presentation and also give you an outlook and discussion impulse for further development in Germany. This is my agenda. First, I would like to briefly introduce our research team so that you can assess us. Then we will take a look together at the heat supply in the new build sector in Germany, identify a trend there, and then, with our eyes thus sharpened, jump to Warendorf. I talk about the planned heat supply and the planning implementation and give advice on planning challenges. Finally, we look to the future together and take away discussion points and lessons learned. A short disclaimer. In this presentation I will talk about low temperature district heating networks. The abbreviation for this is LTDH. Now let's talk about the team. We work in the three thematic areas of wastewater and environmental technology, agriculture and biogas, and the area I present today, sector coupling. We are 45 highly motivated people, and we have to be since we are almost 100% financed by third-party funds and therefore depend on good project and satisfied project partners. But let's get to the topic of today and start with an overview of the heating situation in Germany. This Sankey shows the whole dilemma. The German heating market's dependence on natural gas and oil imports has proven to be a security risk and a major obstacle to climate protection efforts in the building sector. Renewable heat and even more so district heating play only a lesser role in the overall picture. But something is changing. For many years now, the heating structure for new residential buildings has been developing in a different direction. Whereas natural gas was the dominant energy source just a few years ago, with a share of well over 50%, in the course of the last few years, and especially in 2022, there has been a clear increase in the use of heat pumps to the disadvantage of natural gas. Within this development, individual solutions are of course depicted, but they also represent the low temperature district heating systems. More and more utilities and cities are opting for collective solutions, especially in order not to have to give up their customer loyalty. If we look at this map, we see almost 100 low temperature networks in Germany. We created this compilation as part of a funding project in which we are investigating this technology in more detail. I'll talk about that in more depth in a minute. The heat source, geothermal energy either obtained via collectors or probes, clearly dominates. On the grid side, this means low flow temperatures. For the end customer, this means a heat pump. In turn, 3/4 of the networks are made of uninsulated plastic. This is also a sign of the low flow temperature, but also of the fact that the ground along the heating network trenches is also used as a heat source. We are therefore no longer talking about heat losses, but about heat gains. Here you can see the town of Warendorf Markt. The town has a population of almost 38,000 and is located in the north of NRW. The district heating network, which we will take a closer look at in a moment, extends over 18 hectares and includes more than 200 buildings with up to 500 residential units. The planning services for the realization of this heating network were commissioned from Ingenieur Netzwerk Energie EG, INEC, as well as the feasibility study. The first heat pump was already put into operation in September 21, and as of August 23, the district heating network is operating, but still in the construction and realization phase. In response to the pressing challenges of the heat transition in Germany, as they have been for years and decades, my team already carried out two large Interreg projects from 2016 to 2021 to research alternative heat supply methods. One of these projects led to this particular project in Warendorf. It all started when the city of Warendorf and its municipal utility decided to no longer supply new housing estates with natural gas. Based on the results of a feasibility study from the aforesaid previous EU-funded project, the construction area in the Brinke became the first test field for this new strategy. The planning and implementation of the project is funded through the Wärmenetze 4.0 funding program of the Federal Office of Economics and Export Control, BAFA, the predecessor program of the BEW funding you may be aware of. As part of the funding, Stadtwerke Warendorf, in cooperation with us, also applied for funding for the fourth module with the research objective of capacity building, in addition to the funding of planning and construction, and with that task as the only project in Germany. The task of our research team is to bring the technology of low-temperature district heating networks further into the focus of heat suppliers and thus actively contribute to the reduction of CO2 emissions arising in the heat supply. But let's dive deeper. With the decision to implement a low-temperature district heating network comes a considerable, and for most municipalities, utilities and planners, a new planning complexity. Above all, the municipality must take the requirements of the district heating network into account in the development plan. This is mainly done by securing areas for the heating center, the geothermal boreholes, collection and inspection shafts, and of course, the pipelines in the street level. And the city and the politicians have to decide. Do I want compulsory connection and use or not? The town of Warendorf has decided against it, so now the employee of the public utility company has to go from door to door and advertise the system. Although connection to the grid is included in the purchase contract for the plots of land, connection is not a granted thing. But he is doing very successfully. Of the 206 houses to come, just over 100 have already been completed or are in the process of being completed. And only 7% have decided against the connection so far, so that a connection rate of roughly 90% can be expected at the end of the project. Let's now take a look at the network itself. Each consumer has a brine heat pump for hot water and heating. This is best operated via renewable energy, of course. As a heat source serve 116 geothermal probes up to 150 meters deep each. And the heat network also serves as a 5-kilometer pitch collector. And last but not least, the network is controlled via the district heating plant because in addition to the normal operating requirements, each heat pump can be controlled individually in order to optimize network operation. The result is a smart energy system. Now it is high time to come to an end, so let us dare to share prospects for the future. With this project, Stadtwerke Warendorf has opened up a new field of business, from construction and operating to consulting for other municipal utilities and communities. They are now also exploiting the old town area of Warendorf with the 5th generation district heating system fed by a river heat pump. In Germany, a number of developments play a decisive role in the future of heating supply. And even if the new construction sector only accounts for a fraction of the energy demand, it still provides important impetus for the business areas of municipal utilities. The following developments can be observed. The mandatory realization of urban heat plants, likely from 2024. The amendment of the Building Energy Act, likely from 2024 as well, with the requirement for 65% renewable energy for new heating systems. The increased customer demands and of course climate protection targets at various levels. As an opportunity, as already mentioned, and thus as a driver, new business fields for municipal utilities arise and synergies for sector coupling with local renewable energy resources can be developed. I would like to come to an end now, and I think I have been able to present you with a quick insight into an exciting project against the background of a changing energy landscape in Germany. Many thanks for your attention, and I would be pleased to discuss the outcomes with you. But now I look forward to the next presentations, and I wish you all a great conference. Thank you.